Make a table and sketch the graph of f of x equals 4e raised to the power negative x over 3. We can guess from the transformation that this is a transformation of the graph of f of x equals e to the x. First, it is being reflected about the y-axis, and then it is being stretched horizontally by a factor of 3, and then it is being stretched vertically by a factor of 4. But we are going to make a table because the question asks us to. To make a table, knowing that the domain of an exponential function is a set of all real numbers, we can use any number, but usually we use numbers that are close to 0 on the number line. 0 to the right, 0, 1, 2, 3, 4, and so on. And then 0 to the left, -1, -2, -3, -4, and so on. We will plug each of these numbers into the function f of x. X is the placeholder. So for example, when x equals 0, we would evaluate 4e to the -0 over 3. E to the 0 is 1. 4 times 1 is 4. We then plugged 1 into the function 4e to the -1 over 3 and use a calculator to evaluate this. The calculator will give us 2.866 or 2.87. We can round it to one decimal place too, because we won't be able to be this accurate when we plot the points. When we plug in 2, we will get 2.05. Plug in 3, we will get 1.47 or 1.5. When we plug in 4, we'll get 1.05. Plug in 5, we'll get 0.755 or 0.76. And then we plug in -1. This is the reason why we don't want to use just positive numbers. When we plug in -1, we get 4, and then times e to the negative, but x is -1, and then divided by 3. And so this is 4e to the power 1 over 3. We can just simply use a calculator, and this is 5.58. When we plug in -2, we will get 7.79. When we plug in -3, we will get 10.87. And when we plug in -4, we will get 15.17. It doesn't matter what the value of x is, negative or positive, the y values are all positive, however small this is. Armed with this table, we're going to draw the x-axis and the y-axis. But since we don't have any negative y values, we can just simply use a little space for the negative y. Each of the rows from the table will give us an ordered pair. For example, 0, 4. We then plot this ordered pair to get a point on the graph. When x equals 0, y equals 4. When x equals 1, y equals 2.87. Be careful with decimal numbers here. When x equals 2, y equals 2.05. Usually the x and the y do not need to share the same scale. When x equals 3, y equals 1.47, which is 1.5. Again, we cannot be accurate up to that decimal. And I mess up on the interval from 0 to 1 there. When x equals 3, y equals 1.5. When x equals 4, y is roughly 1. When x equals 5, y is 0.76, and so on. When x equals negative 1, y is 5.58. When x equals negative 2, y is 7.79. And so we now have these points. We know that the y value cannot be 0 or negative, and so we will connect these dots, these points, using a smooth curve. And again, we cannot hit the x-axis or go below the x-axis. This is the graph of the function f of x equals 4 times e to the negative x over 3. This function has a horizontal asymptote y equals 0. The domain is the set of all real numbers, and the range are positive numbers only from the interval open 0 to infinity.